Hey everyone. So today we're going to start our new unit on statistics. Now it says here that the statistics is the process of collecting, organize, and interpreting data. Statistics is used to plan and make future decisions to answer statistical questions. Now, a statistical question is a question that has many different or variable answers. Now, this means this is not a yes or no answer question. This is not a question with only one answer. This is a question that if you were to ask someone, you should not have any clue what they're going to say. Now, we're going to go over a couple of examples on what a statistical question is. First, what is Mike's shoe size? If you're to ask this to someone, is there only one possible answer, one possible correct answer? Or are there a lot of different answers that you could say that could work? Well, assuming that Mike has both his feet being the same size, there's only one shoe size that Mike has. Therefore, there's only one applicable answer. So this is not a statistical question. But if you were to say, what are the shoe sizes of students my age? Now, there are a lot of different students with a lot of different shoe sizes, especially of the age of middle school where a lot of people are growing at different rates. So here, this is a statistical question because there are so many students with so many different shoe sizes that it's impossible to pinpoint any one answer. Next, how tall are my classmates? Same kind of deal. You got a lot of classmates, a lot of them are different heights, so there's a lot of different answers that are applicable to this question. It's statistical. However, if you say how tall is Joni, there's only one Joni, and she only has one height. So unfortunately, this is not statistical because there's only one applicable answer. How old is Chris's pet? Chris's pet, singular. So there's only one pet. Chris only has that one pet. There's only one answer, not statistical. How old are my friends' pets? Plural pets, plural friends. A lot of friends with a lot of different pets. They might not all be the same age. So because you don't really know what possible applicable answer this could be, it's statistical. How far does Terrence drive to work? Terrence is one person who drives to their one work, so there's only one distance. Okay? This is not statistical. However, if you were to ask how far do the employees of this store drive to work, there are a lot of different employees. They don't all live in the same place, even though it goes to the same work. Therefore, this will have a lot of different distances, and this is a statistical question. All right? Hopefully by the end of this, you'll kind of understand what statistics is, what a statistical question is, and how you're going to apply it to predictions, and we'll go over that a bit. So, dot plots. We're going to go over dot plots. You may have already learned this, but for those of you who might need a refresher, I'm going to go over what a dot plot is. So, the first thing to do is you need to, I can't write on this, so I'm going to do it over here. You need to create your number line. So here's my number line, la da 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 da. I'm going to make this a little bit thinner. All right. So you need to take these numbers and graph them on this number line. Now right here, I see a 12, so I'm going to put 12 here. And it showed up once, so I'm going to put a little X on top. And that says that 12 showed up once. Next, I have a 3. Okay, so I'm going to put a 3 over here. And that showed up once. Next is an 8. That showed up once. Next is a 1. That showed up once. And then it shows up again with another 1. So that showed up twice. Next is a 6. Next is a 10. Next is a 14 that I didn't account for. So there's your 14 with the X on top of it. Next is another 3. Next is a 6. Next is a 2. By the way, I'm getting all these numbers just from this list here. I'm just counting this list here. So there's a 2. Next is another 1, another 3, another 2, and then 7. All right, this is my dot plot. Now, you can use X's, you can use dots, it really doesn't matter. It's the same kind of concept. I use X's because it's easier for me to draw X's than it is dots right now using this paint program. So you can use dots or you can use X's, I won't mark off. So now that we've made our little dot plot, we can now analyze this data. How many games did the team play during this period? Well, if you want to know, we have to read this. In games played during a 2-week period, a baseball team scored the following number of runs. That means each one of these represents scores gotten in a game. So 12, that was 12 points in a game, 3 points in one game, 8 points in one game, 1 point in one game, and so on and so on. That means each one of these numbers represents a game, right? So that's 1 game, 2 games, 3 games, 4 games, 5 games, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 games that were played. 15 games. Next. What is the least number of runs scored? Well, we can look at our handy dandy dot plot here. Look at the smallest number, 1 point. Yeah. So there were 3 1-point games. That was the lowest scoring game. Luckily it wasn't a 0, but that's fine. So 1-point game. I should write point in there. Next, what was the greatest number of runs scored? So we're going to go to the biggest number here, and that's 14. So there was a 14-point game. And if you have any questions on this, please ask me during office hours. Label the number line, so we kind of already did that. So next, you're going to make a dot plot for this. Let's see, or I guess I can right now. And the biggest thing about this is just to create your dot plot, just to kind of record the data. You're not actually doing any calculations, you're just keeping track of it. So here, we have a 4 that shows up. So that's a 4. There's another 4 that shows up, so we're going to put another X on top of that. Next one is a 9, so 5, 6, 7, 8, 9. Next is a 0. Next is a 2. Next is a 4. Next is a 1. And then another 2. And by the way, if you're having a hard time keeping track, I'm just going in order. So I'm right here right now. Next is an 11. So I'm going to go 10, 10, 11. And then an 8. And then 2 2s. Then a 5. A 3. A 2. Another 5. A 6. A 4. And a 0. Alright, it's just as simple as that. If it shows up, you put an X on top of it. If it shows up 5 times, there should be 5 X's. Hopefully better looking than mine. Alright. Next is a histogram. This is another way of kind of showing how often something happens. However, a histogram is kind of like a bar graph, except every bar represents multiple sets of data. Okay? In this case, we're going to follow this. We're going to make a frequency table. So right now, this is a frequency table, for example. Frequency is how often something comes up. So right now, the interval, because remember, every bar represents more than one thing. In this case, this bar represents from 1 to 4. So any number that shows up that's between 1 and 4 goes in this bar. So 1 to 4, we have no, yes, so that's 1, 2, 3, nope, 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 4, nope, 5, 6, 7, 8. We have 8 numbers that come between 1 through 4. All right. Next, we kind of have this missing number. Let me make this box actually on this side so that I can actually draw it out. So it's 1, 2, 3, 4, 5. Yeah, good enough. So this is the interval. I'm just going to put interval, and then this is the frequency. I'm just going to put FREQ. So in the 1 to 4, it shows up 8 times. Next, they're kind of trying to be tricky here, but it's really not. If this starts at 5 and the next one starts at 9, this obviously has to stop at 8 because that's the next number, right? And if you need me to go over that again, please ask me during office hours. But yeah. 5 to 8, 9 to 12. It's just the natural progression of numbers. Again, here, 9 to 12. The next number after 12 is 13. So I'm going to put 9 to 12, and then 13 to 16. And so with my 5 to 8, how many times did it show up? So remember, I'm looking for numbers 5 to 8. So 12, nope, nope, yes. So that's 1. 2, nope, nope, 2, nope, nope. Nope, 3, nope, 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 4. So this showed up 4 times. Next, my 9 to 12. Yep, so that's 1. Nope, 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 nope. Yes, so that's 2. Nope, 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 nope. So that only showed up twice. Next, 13 to 16. Nope, 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 nope. Yes, and then the rest is no. So this showed up once. Now time to create our histogram. So I'm going to do this in red. Again, always remember to label your graphs. If you don't label your graphs, I have no idea what you're talking about or what you're showing. So please label your graphs. So there's frequency. Here's runs. And then from here to here, I'm going to do 1 to 4. Then from here to here, I'm going to do 5 to 8. And from here to here, I'm going to do 9 to 12. And from here to here, I'm going to do 13 to 16. And then we got our 1, 2, 3, 4, 5, 6, 7. I think the highest is 8, right? So here we have our 1. Let me write this a little bit smaller. Be 16. Let's try that. So there's 1. Yeah, perfect. 1, 2, 3, 4, 5, 6, 7. And of course, my graph is not going to be as pretty as yours obviously will be, because you all make very beautiful graphs, right? Right. Whatever. And then this last one will be 8. Awesome. Cool. So now I'm just going to fill it in. From 1 to 4, it showed up 8 times, so that means this graph is going to go all the way up to here. All the way up to the line, and then fill in. Fill it in. Cool. Next I'll do it in dark blue. Oh no, or yellow. Why not yellow? Next, the next one comes up to 4. So I'm going to go 1, 2, 3, 4, I believe. Now, one of the characteristics of a histogram is, unlike a bar graph, you have to have no gaps. You have to fill it in all the way. So right here, the fact that there's no gap, that is on purpose. So remember, your histograms have to be no spaces. All right. Next, 9 to 12 goes up to 2. I'm going to do that one in pink, because why not? So that's 2. There you go. So there's 2. And the last one, it shows up once. I'll do that one in gray because it's sad that it only showed up once. And there you go. So this is your histogram. And remember a couple things. It's like a bar graph except one, every bar represents multiple things. So everything that could possibly fit in this interval belongs in this graph. 2, there are no spaces between your bars on your histogram. All right? And 3, please make it look better than mine. And that's it for this lesson. We will continue on Wednesday, and please bring your questions to office hours. Have a good day, and I'll see you on Tuesday.